Hello world, good morning, good afternoon, good evening. Welcome to codingscientist.com. You are watching the most exciting series on ESP32, ESP32 CAM and ESP8266. So we have built several projects so far and we are slowly getting into the robotics aspect. So guys, in the last 2 3 lessons, I hope you understood the concept of hooking up the FTDI programmer board into ESP32 CAM board and start uploading the codes. And you did try to play around with the example codes, publish the videos on the webs and stuff like that. Now, in this lesson, I will show you how to build a very simple pan and tilt robot, right, with two different motors and stream a live video on the web. While turning, you can also turn the motors in four different directions through the web browser itself. You can place the robot anywhere within the network, in your home or office or somewhere, and you can sit in a different computer and start controlling the pan and tilt motion of two different motors and the ESP32 cam sitting on that. We will basically attach the ESP32 cam to a pan and tilt stand. It's basically a 3D printed stand, you can make it yourself, with two SG90 servo motors. It's a simple, 150 rupees small little tiny motors. That's the one which I'm using it, with pan and tilt camera as a stand and a kind of movement on top. You can move the camera up, down, and to the left and right. That is the overall functionality of this particular project. And this can be used as a surveillance robot or surveillance, a standalone mechanical bot, right? The ESP32 CAM basically hosts a web server which has been modified from the example example code which came along with the bundle when you install the board manager, right? So we can modify that code and make it use the same web server to attach your GPIO pins and control the motors by sending out the signal. So and it will basically create a four different buttons on your HTML text, a simple button and the web and the browsing window. So what you need to do is, guys, it's very important. Go ahead and hook up, first most important thing, hook up your FTDI to your ESP32 cam as per this particular drawing, and make sure that everything is perfect, no loose connections, nothing. And then what you need to do, you got to follow these rules which I had been showing in the last 2 3 lessons, right? You got to follow these points very strictly, because this is purely based on my research, the pain I had undergone through while uploading the codes. There are several methods to upload, doesn't work, it doesn't upload at all. But if you follow these points, you will be perfectly be able to upload the codes into your ESP32 cam. So go ahead and do this, follow this method. And then the next step, upload the codes to ESP32 cam before you start wiring your pan and tilt motor, two SG motors. Before even starting to build the circuit, first you upload the code and then open the serial monitor, look for the IP address, and then open a browser, put that IP address and see if the video is streaming. You will see four different buttons, right? Nothing else. And then you unplug, disconnect everything. Do not do anything, just disconnect. Make sure that you upload the codes before the circuit, before building the circuit. All right. The reason is, of course, we will be using two different GPIO pins of ESP32 cam to connect your motors. And then once you fix it and mount it, you may not be able to reset. That's another challenge, because your reset button is at the bottom of ESP32 cam board, which is kind of, as per design, it's definitely not good, but can't help. That's how it is. So that's the reason. Go ahead and load the code first, and then come back to the circuit, which is what I will show you in the next slide. But you can go ahead and pick up this kind of pan and tilt 3D printed stand, which comes with the SG90 motor, which is available in Amazon or anywhere on the site. You can just Google it up. The entire kit, the pan and tilt, should not cost you more than few $100. You can also 3D print. You can, if you have the 3D design and the 3D printer, you can print it and buy two motors and connect it like this. And then go ahead and build the circuit like this. Your two different motors, of course. The positive and the negative, which is the ground and the VCC pin, is the common pin, and the signal pins are the yellow lines, which is connected to your GPI of 14 and 15 of ESP32 cam. So that is where your signals gets triggered, right? Now what we will do is, let's take a look at the code, guys. The way I had built, let me show you my circuit the way I had put together. So this is how it looks. I just put a temporary structure on the breadboard to test it, and make sure you are using 3.7 volt battery, guys, because we will not be able to hook up your ESP32 cam with the FTDI driver, FTDI board once you build the circuit, right? So you have to power up through the breadboard and use this kind of 3.7 volt 18650 battery. So do not power up more than 3.7 volt. Maximum you can give is 5 volt. Do not increase that, you might end up damaging your board. All right, now what we will do, let's take a look at the code, and then we will come back. So before we take a look at the code, guys, so what you need to do, go to my GitHub account. Okay, go to my GitHub under ESP32 cam section. In this section you can find here pan and tilt robot.rar. It's a zip file. It's a pan tilt robot with video streaming on the web. That is the name of the file. So go ahead and download this file, download the zip, then you can extract this. Once you extract, you will get a .ino code, which is for Arduino, right? And then this is what the code is all about. You can open it and make sure that you have this library installed, that is ESP32 servo.h. How do you install this library? Let me show it to you. Go to sketch, go to include libraries, go to manage libraries, and this is going to refresh your library list. It will take about a second. Let it get refreshed. Once you get this window, in the search bar, in uppercase type ESP32 and then uppercase S, lowercase servo. You should get that library in a minute. There you go. The first one by Kevin Harrington. So this is the library you should install. This is the perfect one. Do not install the second one, that is still under trial version. So do not install that. You might end up with some mistakes. So go ahead and install this library, which allows ESP32 board to control the servo motors using Arduino semantics. That is great and looks powerful. Let's go through the info. I would highly advise you guys to read through this documentation about any of the libraries. This is for your own skill development. You need to understand how the libraries are compiled and built and compiled. So this is taking you to the Arduino reference site where all the libraries are there. So that's a pretty good documentation with versions and stuff like that. Go ahead and read so that you will get a hang of how these libraries are. All right, so once it is done, and now you know how to upload the code very well. I had showed you. Before you upload, make sure you change your SSID to your Wi-Fi ID. Okay, it should be your Wi-Fi ID and your password. And then once you upload, right, before uploading, make sure that you follow the rules, right? What are the rules I showed you? What wire to connect? It should be in 3.3 volt. And then in case if you see the dots here, if it doesn't upload, right, but it doesn't show any error, click the reset button once for a short while and leave it, right? It'll upload successfully till you see this writing to 100%, writing at 100%, and at the bottom this one, right, hard resetting via RTS pin. This is the message you should get at the end. All right, guys, so till then you have to leave it. So go ahead, upload the code, and keep things ready, and then come back to the circuit, build the circuit, build it, keep it ready. Right now let's do some testing. So what we can do is, let me show up my circuit. All right, I'm going to hook it up with a battery. I have 3.7 volt 18650 battery. I'm going to hook it up. There you go, the motor turns, and I'm going to open up the browser, which is on my right hand side. I hope you guys can see it. I'm going to put my IP 192.168.0.100 and the camera streaming is happening. All right, I hope you guys can see. Let me just move the camera here. Okay, I hope you can see the up and down buttons, right? If you see up, down, left, and right, these are the buttons as part of your HTML, the button, the program which has been included within the servo library, within the main program. So go ahead and build it. You will get this video streaming on the browser, and once you get it, I am going to click up and down and show it to you how this works. Let me click. Can you see the motor rotating? That's fantastic. That's great. Let me click left. It's moving towards left. Let me click down and it's moving upwards. That means the wiring which I did is kind of interchanged, so I can change the wiring to make sure that it's rotating up and down. And I'm clicking up. It's moving down because of the wiring. Let me move it down. Let me lift it on top and then click right. Okay, right and left seems to be working perfect in the perfect direction. That means the polarity of the wirings seems to be correct. Let me click left. All right, let me show my hand on the camera. Can you see it here, guys? The camera is actually towards the other camera, so that's why I'm just showing my hand. So looks like the frames per second, the FPS seems to be good while transmitting on the web, right? It looks pretty neat. I don't see any lags and kind of thing. So which looks to be okay, but we can do ton loads of modification here, right? We can do a lot of modification, guys. Let me turn it towards right again. It's turning right, down, up. That's pretty good for such a small little low cost camera. The motion seems to be really, really perfect. Alright guys, so that's about it for this project. What we will also do is use the same method of moving the motors left and right and kind of thing. Plus the previous lesson of color detection, right? Detecting the color and detecting the faces which I showed you in the previous lesson. Go ahead and play with that example. We are going to combine that code with this code with two different motors and try to build a bot in the next lesson. This is already a bot. This is a pan and tilt bot, right? But if you see carefully in one of the sessions, I showed you a kind of rover bot. That is what we are going to build. That is the ultimate game. It's like a capstone project, right? So we are going to build that rover in such a way that you can control the robot, the rover, sitting on your desktop on the browser, right? Or on your mobile. You can open the browser on the mobile and control the bot. It will just keep moving around left and right, left and right, left and right, keep throwing the video, right? It's a same principle of this particular project what we built on pan and tilt, right? It's going to do is detect the objects here, and then the pan and tilt motion is going to work left and right. So it's kind of combining both the codes, actually three different projects together: detecting the face or detecting an object, and then controlling through the browser and moving the motors through GPIO. So it's going to get interesting, guys. All right, see you soon. Until then, goodbye.